Alrighty, you guys, today is your review day. We're going to be going over the review notes, which means that next class will be your test. Okay, so a few things we've talked about this unit. Okay, we've talked about a few different ways to find missing sides or missing angles of right triangles. So this whole unit we're dealing with right triangles. So go ahead, let's go ahead and flip your paper over. Hold on, I'm grabbing another piece of paper, but for you guys, just flip your paper over. Okay, and let's talk about the different things or the different ways that we've found how to find missing sides or missing angles. Okay, so first of all, let's talk about finding missing sides. Finding a missing side of a right triangle. Okay, so the first way that we talked about was using the Pythagorean Theorem. Okay, so the Pythagorean Theorem we know as a squared plus b squared equals c squared, and we'll go over an example where we're using it. Okay, but when do we actually use the Pythagorean Theorem? Okay, well, the Pythagorean Theorem we use when we know two sides of the triangle already. So it gives you two sides, you're trying to find the third side. Okay, so that's the first way we talked about finding a missing side. The second way is sometimes it doesn't give you two sides of the triangle. Sometimes it gives you an angle and a side. Okay, so this is where we have to use trigonometry. We'll just say trig. Or in other words, this is referring to SO, CA, and TOA. Okay, our three trigonometric functions, sine, cosine, and tangent. These ratios have to do with like the sides, right? Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Okay, so we need to use trig when we know one side and one angle. Okay, so we're given one side and one angle. We need to then find that missing side of the triangle. Okay, and the third way that we talked about finding missing sides was special right triangles. Okay, so there are two different types of special right triangles that we talked about where basically they have sides that start a certain way. Okay, so the two different types of special right triangles we talked about, the first one, we call it the 45, 45, 90 right triangle. The reason we call it this is because we have our 90 degrees, and then the other two angles are both 45 degrees. Okay, if we know one of them is 45, we know the other one has to be 45 as well. Okay, and the way this special right triangle starts, so think of it at its most basic form. Okay, well, the two sides, since their angles are equal to each other, 45 is equal to 45, their sides are always equal to each other, and it starts at 1 and 1. Okay, then if you remember a few classes ago, we proved using the Pythagorean Theorem what our hypotenuse side would be, using a squared plus b squared equals c squared, and we proved that the hypotenuse has to be root 2. Okay, so in its most basic form, this is how that special right triangle starts. Okay, our other special right triangle that we talked about was our 30, 60, 90 right triangle. Okay, so this is a little bit different. I'm gonna try and make it look a little different than our first one. Okay, still a 90-degree angle. Okay, but then we have 30 degrees that's going opposite of our smaller side, and 60 degrees that's going opposite of our longer side. Okay, well, in its most basic form, there are a couple memorization tricks I like to use here. Okay, so we know that the hypotenuse for 45, 45, 90 is root 2. Okay, well, the hypotenuse for 30, 60, 90 is just a plain 2 or a regular 2. Okay, so think the hypotenuse is always some type of 2. Okay, then my other memorization trick was that the 30 angle, the side that is closest to the 30 angle, think 3's got to go next to 3. So this side was root 3. And again, we proved these sides using the Pythagorean Theorem a few classes ago. Okay, well then the only other side on this right triangle that I'm missing is the short side. And we know it's 1. Okay, so using those most basic sides or how they start out, we can tell that if a triangle is one of these two special right triangles, we don't even have to use SOHCAHTOA, or the Pythagorean Theorem because we know how the sides started. Okay, and we'll do a couple of examples in a minute. Okay, so these are the ways we can find missing sides of right triangles. Talked about 3 different ways this unit. Okay, so go ahead, turn your paper back over. Now let's go ahead and use this. Okay, so let's look at number 1. So it's asking us to find the missing side, but we know that we are given 2 sides. We're trying to find the third. So that automatically tells me I need to use Pythagorean Theorem. A squared plus B squared equals C squared. Okay, now we just need to remember, well, which side's my A, B, and C? Okay, well, we know that the hypotenuse, the side across from the right angle, has to be our C. So root 10 is our C. Okay, our 2 legs is what they're called. They can be A or B. So I'm just gonna go ahead and make root 7 my A. X can be my B. Okay, so now that I've identified those sides, all I gotta do is plug those numbers into my theorem. Okay, these guys are ugly. That is okay. We're still gonna plug them in. So A squared, well, my A is root 7 squared, plus B squared, my B is X, so X squared, equals C, my C is root 10, so root 10 squared. Okay, awesome. So now, looks really ugly again, but what do we know? We know that the square root and square are actually opposites of each other. Okay, so those 2 cancel each other out. All we're left with is what's inside, or just 7. Okay, can't square a number if we don't know what it is, so that's got to stay X squared. But then again, square root and square, opposites of each other, cancel each other out. So we're just left with 10. Cool. Alrighty, so now from here, I'm just trying to get X by itself. It just becomes an equation that I need to solve. So work from farthest from my X, got to get rid of this positive 7. So we do the opposite, which is to subtract 7. Come over here for some more space. Still have X squared on this side. On the other side, I now have 10 minus 7, which is going to give me 3. Beautiful. Okay, my last step, get rid of the square on the X by, yes, square rooting it, doing the opposite. And remember, we have 2 different ways we can type this answer in your computer. Okay, the first way is the exact. So if you see an equal sign, just like this, okay, it just wants you to leave it as a radical. Okay, so this is the exact answer. So if you see the word exact or just the straight equal sign, it means keep it like that. Okay, our next way is our decimal. And whoops, okay, you might see like a squiggly equal sign. Okay, here it just wants you to bring out your calculator. I have second, X squared button gives me the square root 3, and I get my decimal. Okay, let's go ahead and just for practicing sake, let's round it to the nearest hundredth. That's my second place. Okay, so look at the third. It's a 2, not gonna bump it up, so my decimal is 1.73. Okay, and this is the decimal form. Okay, so 2 different ways your computer might ask you to put in those answers. They're both technically right. Okay, so that's the one where we had to use Pythagorean Theorem. We know 2 sides, you gotta find the third. Okay, for numbers 2 and 3, still asking us to find the missing side. Okay, but this time we're not given 2 sides. We're given a side and an angle. Okay, which if you look at the back of your paper, this tells us we have to use SOHCAHTOA. Okay, so I'm just gonna go ahead and write that out first of all. SOHCAHTOA, because we know we're gonna have to use one of these functions, sine, cosine, or tangent. Okay, well remember, we are standing, we're standing at the angle it gives me, or the angle it indicates. Okay, that's 53 degrees. Based on where I'm standing, the 2 sides that I'm now working with are my opposite side, okay, so opposite of that angle where I'm standing, and then my hypotenuse. Okay, so we don't care about the adjacent side. It didn't give us that one. We don't care. Okay, so which function, sine, cosine, or tangent, are we going to use because it works with opposite and hypotenuse? Okay, well, I know it's going to be sine. Okay, which means we don't care about those guys. They are not going to help us here. Okay, so here's how we set up our equation. So we have sine, since we're using so, of the angle. Remember, the degree always goes next to it. The angle degree. Sine of 53 equals opposite 12 over hypotenuse x. Okay, couple steps to finding this, or solving for x, finding the missing side. First thing we got to do is look at our side with our x, but we notice it's on the denominator. Well, we got to get rid of that, okay? So we got to first do the opposite of divide by x, which is going to be to multiply by x. Okay, so now on this side, I have x times sine of 53 equals 12 was the only thing left. Okay, well, all we did was move our x to the other side. It's still not by itself. So now look at the other side with our x. Well, what's the opposite of times by something? Just do the opposite, which is to divide by that thing. So we are going to divide by sine of 53 on both sides. Okay, all we got to do is type that into our calculator, and it's going to give us our x. Okay, so in my calculator, I'm going to type 12 divided by sine of 53, close parentheses. Let's go ahead and round it to 2 decimal places. Okay, so look at the third. 5 is going to bump it up, so final answer 15.03. And there's our missing side. Okay, so that's where we had to use trig. Let's try that one again. Okay, so for number 3, we're still using trig. You are standing at the angle it gives you, so we're standing at 30 degrees. Now, based on where we're standing, what 2 sides are we working with? We're working with the side that's right next to where I'm standing, so that tells me adjacent. Across from my right angle, again, hypotenuse. Okay, so I'm just going to go ahead, still write out my functions. So, ca, or toa. Okay, now which function, sine, cosine, or tangent, so ca or toa, am I going to use because it uses adjacent and hypotenuse? I know it's going to be cosine. Okay, so now I can set up my equation. Cosine of the angle, so of 30, equals adjacent over hypotenuse, x over 11. Whoops, don't know why I did an h there, but that's 11. Okay. One thing I got to do, because my x is not on the bottom anymore, so I don't have to move it. All I got to get rid of is this divide by 11. It looks like a divide by h. Well, we do the opposite, which is 2 times by 11. Okay, so now to get our x on this one, all we got to do is type that into our calculator. 11 times cosine of 30. 2 decimal places. Third decimal place, it is a 6. It's 5 or above, so it's going to bump up the one in front. 9.52. Okay. Beautiful. Now, for numbers 4 and 5, we're not trying to find a missing side anymore, but we're still going to use so, ca, or toa. This time we're finding the missing angle. Okay, so we're given 2 sides, find the missing angle. Still going to have to use sine, cosine, or tangent, or so, ca, toa. Okay, so again, standing at the angle that it indicates, standing right there. Let's go ahead and just change that question mark to an x. Okay, now based on where we're standing, what 2 sides are we working with? Well, opposite of that angle, opposite. And then the side next to that angle, adjacent. Okay, so now which function am I going to use because it has opposite and adjacent? Okay, well, I know it's going to be tangent. Okay, so now we set up our equation. Tangent of x, because we actually don't know what that angle is. Tangent of x equals opposite, 39, over adjacent, 28. Okay, so we're still trying to get x by itself, but how are we going to get rid of tangent that's next to it? Okay, this is not being times by tangent. Tangent is a function itself, just like multiplication is a function. Okay, so we actually have to do the opposite of tangent, which sounds pretty redundant, but it literally means the opposite of tangent. We call it the inverse tangent. Okay, so in your calculator, you're going to do the inverse tangent, and I wrote it in the back. Actually, you're going to type it in the front, okay? The inverse tangent of this fraction. So now in my calculator, you're going to want to click second, because you see above the tangent button, it has your little tangent, -1, inverse tangent. So inverse tangent of 39 divided by 28. There's our decimal. Let's go ahead and round it to, let's practice rounding to 1 decimal place. 54 point, just 1. It's a 2 behind it, so it's not going to round it up. 54.3. Actually, it wants it rounded to the nearest degree. Let's go ahead and just do that. Okay, well, if it was 54.3, the 3 is not going to round it up. So we'll just say 54 degrees. And that's ugly. That's okay. Okay, so let's try that one more time. A couple different buttons we're using here. Okay, so again, standing at the angle it's indicating. Go ahead and just change that question mark to an X. Okay, well now what are the two sides it's giving me? It's giving me opposite, and then the side next to it, adjacent. Okay, well again, what function are we going to use? So, ka or toa. Which one uses opposite and adjacent? Again, we are using tangent. Okay, so set up my equation. Tangent of x, the angle, equals opposite, 1, over adjacent, 2. All right. Well, again, we look at our side with our x, and I need to get rid of tangent. Well, the opposite of tangent is inverse tangent. Literally means the opposite of tangent. Okay, so we're going to take the inverse tangent of that fraction. Remember, type it before the fraction. Okay, I just didn't have room to write it there. But our x is all going to be by itself. So now I do, again, second inverse tangent, 1 over 2. Okay, let's round it to the nearest degree, meaning nearest whole number. Well, 26.55 and above rounds it up. So that angle is going to be 27 degrees. Awesome. Okay, so we've talked about finding a missing side using Pythagorean Theorem. We've talked about finding a missing side using SOHCAHTOA, or TOA, and we've also talked about finding a missing angle using SOHCAHTOA, or TOA. Now, for our last examples of the day, we need to find the missing side lengths by using our special right triangles. Okay, so let's go ahead and look at number 6. Okay, well, first things first, I need to identify what special right triangle it is. Okay, well, here's 60, so that means that guy's got to be 30. So this is a 30, 60, 90. Okay, so now that we've identified which special right triangle it is, now we can identify how the sides started. Okay, well, the side closest to, actually, what color? Yeah, the side closest to 30 degrees, remember the 3's got to go together. This started as just root 3. Okay, this side, the smaller side, starts at 1, and the longer side started at 2. Okay, well, how are they going to change? This guy went from root 3 to 3 root 3. So, what did we multiply to root 3 to get 3 root 3? Okay, well, pretty simple. We just multiplied it by that 3, which changed it to 3 root 3. So now for my other sides, I'm just going to take the other sides, which started as 1 and 2, multiply both of those sides by how they changed on the first side, 3 and 3. And we're going to get our missing sides. Okay, well, 1 times 3 is 3, so I know V is 3. 2 times 3 is 6, so the U is 6. So my two missing sides, V was 3, U was 6. And there we go. We didn't even really have to solve anything. We just had to identify, okay, how did this side change? Well, that's how the other two are going to change. Okay, so let's go ahead and do that again. Okay, so what type of special right triangle is this guy? This guy, if that's 45, we know that angle also has to be 45. Okay, well, we know that the two legs in a 45, 45, 90 are always equal to each other. So if this guy's 5, well, actually, I'm getting ahead of myself. Okay, so this guy started as 1. Okay, we do know that they're equal to each other, those two sides. Okay, this guy starts as 1, and then this guy, our hypotenuse, starts as root 2. Okay, so my first side, I somehow went from 1 to 5. What did I multiply to 1 to get 5? Okay, pretty simple. I multiplied it to 5. Okay, which means I'm going to have to do my other sides, my other 1 and my root 2, multiply them both by those 5 and 5 to find my other two sides. Okay, well, my other side, 1 times 5, 5. And root 2 times 5. How are we going to write that? Don't worry, that just goes right in front. So 5 root 2. Okay, so my y, my other side, which we were saying they have to be equal. So y is 5. X is now 5 root 2. And there are my missing sides of this right triangle. Okay, one more example. This is what we call a multi-step because there are actually two triangles here. Two special right triangles. Okay, well, let's go ahead and focus on the bigger one first. We'll focus just on this guy, especially because it's giving me one of the sides to that triangle. Okay, well, I know this is a 30, 60, 90, because that guy was 60. Okay, this side started as root 3. This side is going to be 1. Or started as 1, and this side started at just a plain 2. Okay, well, somehow I went from root 3 to 7 root 3. Okay, so for my purple triangle, I went from root 3, multiply it by something to get 7 root 3. Okay, well, I know I multiplied it to the 7. Okay, so now I'm going to find my other two sides. 1 had to multiply by 7, and 2 multiplied to the 7. Okay, that means my other side is 7. That hypotenuse is 14. Okay. So this 7 side, this other side right here, is really going to help us, okay, because now I need to find this other side that'll help us find the hypotenuse. Okay, so this special right triangle is now a 45, 45, 91, which means these two are equal. Okay, so if this side is 7, that side is also 7, but our end goal is to find this hypotenuse. Okay, so now in a special right triangle, this guy is 7 My other guy is also 7, which he started out as 1. So 1 times 7 gave us 7 over here. Again, the other side's also 1 times 7, and my hypotenuse started as root 2, which we now need to multiply to 7. Okay, well, what is my end goal? This guy right here, my x, is my end goal. So what is 2 times root 7 going to give me? What is that final missing side going to be? Okay, well, that 7's just going to go right in front and give me 7 root 2. And there we go.